We're now going to have a look at how we name alkenes. So in the previous video, I showed you that the simplest alkene that we can have is ethene. So ethene, in terms of the displayed formula, is just this. Okay, it's got one double bond in it, so it shows it's got the alkene functional group. It's got 2 carbons in it, so this is called ethene. Okay, so ene means it's unsaturated, it's got a double bond in there, and you've got 2 carbons because of the eth. The next one is with 3 carbons in it. Okay, so this one here, again, it's got a double bond in it, so it's got to end in ene. It's got 1, 2, 3 carbons, so this one here is propene. Okay, in terms of the shape in propene, so I've just kind of got a model of propene over here. So it's got 3 carbons, 1, 2, 3. Between these 2 carbons here, we've got a double bond. So again, we've got restricted rotation around there, and each carbon has a trigonal planar shape. Okay, so this one is trigonal planar. It's got 3 bonding regions. This one here is also trigonal planar. It's got 3 bonding regions. So the shape around this one, the bond angle around this one is 120, and so is this one. That kind of methyl group up here is this one, okay? Because we've got a double bond between these carbons, we've got free rotation. Because we've got a single bond between these carbons, we've got free rotation, so I can rotate this freely. Okay, so anywhere you have a single bond, you have free rotation. Anywhere you have a double bond, you have restricted rotation. Okay, around this carbon, we've got 4 bonding pairs. Okay, so we've got 4 bonds, so 1, 2, 3, and 4. So this shape is actually tetrahedral. Okay, so within one molecule, you can have more than one shape and bonding angle. So these ones are trigonal planar, and around this carbon, it's tetrahedral, and therefore the bond angle is 109.5. So just be aware of that. You can have more than one shape within a molecule. Okay, right, so after propene, we can obviously have one with 4 carbons in it, which you'd then assume is called butene. But there's a slight difference when it comes to when you've got more than 3 carbons in there, because the double bond can be in different places on the chain. Okay, so first one, I'm not going to draw these bond angles correctly, just so I can show you the 2 different ways we can do this. So we've got a butane chain, so we've got 4 carbons. In this one, I can put the double bond at the beginning. In this one, I'm going to put the double bond in the middle. Okay, I'm just going to draw the other hydrogens in. And I have to keep in mind that each carbon must have formed 4 bonds. Like so. Okay, so both of these molecules have 4 carbons. Both of these molecules have 1 double bond. So these are technically both called butene. Okay, so this one here is butene, this one here is butene. But as we can see, they're actually different molecules. In this one, the double bond is right at the beginning. In this one, the double bond is in the middle. So now what we need to start doing is finding a way to distinguish between these 2 types of butene. Okay, and in order to do that, we need to say what the position of the double bond is. And the way that we do that is by numbering the chain. So the carbon chain, we're going to number this. So 1, 2, 3, 4. This one as well. And what we do is we look at which numbers the double bond falls between. So this one is falling between 1 and 2. And from there, I pick the smallest number. Okay. And then what I do is I put that, so this one, the smallest number is 1. So I put that just before the ene. Okay, so this name has got to end in 1 ene because it's 4 carbons. This is called but 1 ene. Okay, and if we go to this one, the double bond falls between carbons 2 and 3. I pick the smallest number out of those 2. So this one here is called but 2 ene. Okay, so I have to remember, in terms of numbering it, I must start from the side where the double bond then falls on the smallest number carbon. So if I started numbering from here, it would be called 1, 2, 3. So technically, you would have called it but3ene, but that's incorrect. That's not the correct name for this, because we've got to start numbering from the side where the double bond falls on the smallest number carbons. In this one, it didn't matter because the double bond's right in the middle. Okay. These two molecules here, they have obviously the same molecular formula, but they have different structural formulae. So that means these two molecules here are structural isomers of each other. And that's what we looked at when we were looking at alkanes, and you can have that within alkenes as well. Okay. If I wanted to show this molecule as the skeletal formula, so it's got a butane chain, so it's got 4 carbons, and the double bond falls between carbons 1 and 2. So I draw it like that. This one here, double bond falls between carbons 2 and 3, so I draw it like that. Okay. Right, let's move on to the next one. So after but, we have pent, that's 5. I'm going to draw the skeletal now. Okay, and the other one here. So we can have one pentene where we have a double bond there, and the other one is where it's over here. Okay, so in terms of naming these, got to number. And this one, I'd start numbering from here to make sure that it falls between the smallest number carbons. So this one here, it's 5 carbons, so it's pent. And double bond falls between 1 and 2. Smallest number is 1, so this is called pent 1ene. Okay, so me putting the number just before the ene means that the ene, the double bond, is found starting from carbon 1. This one over here, 5 carbons, pent, double bond falls between 2 and 3, so this is pent 2ene. Okay, and again, these are structural isomers of each other. Same molecular formula, but different structural formula. Okay. Let's do some more examples, so just so we get used to the names. So if we go for this molecule, that one there, okay. So number of carbons, 1, 2, 3, 4, 5, 6, 7, 8. So that's oct. So it's going to start with oct. In terms of numbering, I need to start from this side. If I start from this side, the double bond is going to be on a larger number. So if I start numbering from here, 1, 2, 3, 4, 5, 6, 7, 8. And therefore, double bond falls between 3 and 4. So this is called oct 3ene, like so. Okay. We've just been looking at straight chain or unbranched alkenes. Let's now have a look at some branched alkenes and how to name those. Okay, so just double check, each carbon has 4 bonds. Okay, this molecule here, we need to find the longest carbon chain, but the longest carbon chain should include the double bond. Okay, the reason I say that is because we could go across here, so 1, 2, 3 here, but I could go 1, 2, 3 here. Okay, if you've got a double bond, the double bond takes priority, so the double bond should always be in the main chain, and it should be always on the lowest number carbon. Okay, so it takes priority, so we make sure this is in the main chain. So the longest carbon chain we can get with the alkene in it is 1, 2, 3 going across here. Okay, so that means this is going to have prop in it. Okay, with propene, in the example that I showed earlier, we don't really show the numbers in that one because it's always going to be at carbon number 1. Okay, so it can't ever be at carbon number 2, because if it does start at carbon number 2, so it would have been here, that's still technically carbon number 1 because we start numbering from here. Okay, so I don't actually need to have a number for propene. Okay, so only when you get to bute do you start need to put numbers in for the double bond. Okay, so this is our propene chain, and we have our methyl group, okay, our CH3 coming off at carbon number 2. So this is called 2-methyl propane. If I were to draw the skeletal for that, it would look like that. Okay, let's do some more. Okay, so again, we look for the longest carbon chain that has the alkene in it. So in this case, it's going to be going across here. So this in this case is going to be pent. And in terms of numbering it, so I mean, obviously you've got two options. You could start numbering from here, or you could start numbering from here. Okay. With alkanes, we want our branch to be on the smallest number, carbon. But now if you've got an alkene and you've got a branch, the alkene takes priority. So it goes on, is the alkene that goes on the lowest number carbon. So that means I start numbering from here. Okay, so this molecule here, the double bond is between 1 and 2. So this is pent 1-ene. And the branch is coming off of carbon 4. So this is 4-methyl pent 1-ene. Okay, let's do some more examples of this. Like so. Okay, so again, longest carbon chain in this case again is the one going across through the molecule. We want the double bond to be on the smallest number carbon, so I start numbering from here. So this molecule has 6 carbons, so it's going to be hex. Double bond falls between 2 and 3, so this is hex 2-ene. We've now got 2 methyl branches. Okay, so if you remember, if you've got 2 methyl, it's going to be dimethyl. And you've got to say what numbers they're on. So this is coming off of 2 and 3. So this is 2, 3, dimethyl hex 2-ene. Right, all of these ones that I've done so far, because they are aliphatic alkenes and they only have one double bond in them, they all follow the CnH2n rule. Okay, so they all have the same general formula. Let's now have a look at ones that don't follow that general formula, so they're not in the same homologous series as alkenes. So that can be where we have more than one double bond in a chain, or when we have cyclic alkenes. So let's just look quickly at how we name cyclic alkenes. So cyclic means it's in a ring. So if we look at this one here, obviously we can rotate this anyway. So if I'd drawn that out, they're exactly the same thing. I've literally just rotated it. Okay. So this molecule here, it's got 6 carbons in it. So therefore it's going to be hex. Okay, we've got 1 double bond in there. We don't need to number it because there's literally just 1 double bond. So technically it is going to be hex 1-ene. So we don't need to put the number in here. So this is hexene. Okay. And because it's in a ring, this is called cyclohexene. And if we have this one here, it's got 5 carbons in it, so this is going to be pent. And again, because we're in a ring, there's no kind of starting position. It's got the double bond's got to be on carbon number 1. It's pentene. We don't have to put the number in. And this here is called cyclopentene. Let's also look when we have more than one double bond. Like this molecule here. Again, doesn't follow the CnH2n rule. In terms of numbering, we should start numbering from this side. So 1, 2, 3, 4, 5, just to make sure the double bonds fall on the smallest number carbon. So this is going to be pent. And now because we have 2 double bonds, so the prefix for 2 is di. So this is going to end in di-ene. So the di means we have 2 ene, so 2 double bonds. And then we need to put the numbers in for them. So we have a double bond between 1 and 2. So that's going to be 1. And we have a double bond between 3 and 4. So that one's going to be 3. So this molecule here is called pent-1,3-diene. The two numbers here are applying to the diene part. The di means we've got two of them. If we have 3 double bonds, like so. So again, I'm going to start numbering from this side to make sure all the double bonds form the smallest number carbon. So this is a heptane chain, or heptene chain. So it's going to be hept. Because we've now got 3 double bonds, this is going to be tri before the ene, so it's triene. Okay. And we just now got to put the numbers in. So this one is going to be 1, this one's 3, and this one's 5. So this is called hept-1,3,5 triene.